Our next lecture is from Ivaylo Bachvarov. He is the CTO of Hacksoft. He's a co-founder of Hack Bulgaria as well. He's also a very nice friend and a passionate developer using Django and React. You probably met him as the MC last year, but I took his job from him, so please, take it away, Ivaylo.
Thank you. So, hello everyone. As you already know from this lovely introduction that Gennady made, I'm Ivaylo Bachvarov, and it is the first time me being actually on the stage having a real talk, so I'm extremely excited about this. As he said, I'm a CTO at Hacksoft, which means a lot of things, but I am a software developer. A software developer that for the last, let's say, 10 years is doing web applications from simple website at the beginning to complex big systems that are kind of important and people are using them every day. But today, I'm not going to talk about how to write this kind of applications, but I'm going to talk about end-to-end automation testing, something that is pretty new for me, and I have a pretty interesting standpoint as a developer, so it's not like I have any experience with the QA or something. So let me bring a little bit of a context here. 6 months ago, we started developing a system that looks like most of the systems that you are familiar with. It's basically the same thing that I'm doing for the last couple of years. Having a single page application on the front end, some backend, using some APIs for communication, a database, of course, and a couple third-party integrations. So you're probably really familiar with this kind of architecture, and you probably can recognize your project in there, because this is nothing really special. It's a little bit, this picture is a little bit simplified. In reality, it's a little bit more complex. We have some message brokers, some background task runnings, some of the flavors of the modern web development, but in order to simplify it, just a single page application, no matter what, React, Angular, what you decide, and then a backend. In our case, it is a Python and Django. So my team, it was a small team with 4 developers, developed a system for, let's say, 6 months that was pretty mission critical. And by mission critical, I mean, imagine, let's say, an event management platform where if the platform is not running, let's say, for 5 minutes, the whole event, the whole work that a lot of people put it into this event is going to be gone. So it is not like the typical software solutions that we were doing, where if something is not working, someone is going to report it to the support, and then we are going to know about it, we're going to make a ticket, and at some point eventually fix it, right? So here we are speaking about mission-critical software, which is not every case, right? This is something that needs to be working and needs to be working perfectly. So in order to be absolutely sure that before an event, our event management system is working, we were doing a lot of manual testing. Our first event was, let's say, in 2 weeks' time, and we wanted to ensure that the system is working, every feature is working, and it's working the way it should be. So when the event kicks in, everything is how it should be. So our first approach was manual testing. As developers, pragmatic people, we decided to create a spreadsheet and describe all of our tests in a document there. Just a simple spreadsheet that is describing our end-to-end manual tests. So we created a little structure marking, when the test was created, when was last time it was executed, is it passing or not, but just a spreadsheet, nothing too fancy. We tried a couple test management systems, but spreadsheet was more than enough for now. So yeah, describing all the steps there, like for example, open the sign up window, enter your email, enter the password, then click save, and then a message should appear, hey, you're registered. Registering for an online event is a pretty critical part. If it is not working, a whole event may be great, but no one is going to attend. So this is kind of a core part. We described all the core features in a spreadsheet, and before each event, we were manually doing this kind of testing. And it was pretty good. It was working. The document was, we tried to keep it up to date, and everyone can actually execute these manual tests. The problem came when we started to have a couple events a week. So we cannot afford stop any development, focus a day on testing, because at some point we had around 100, 200 tests. and then ensure that the system is working. So we needed something faster. We needed something that ensures that the system is bug-free like every day or even a couple of times a day. And obviously, manual testing was not a long-term scalable solution for us. So we decided to start Automate. This was the obvious thing that we needed to do. We already know what needs to be tested. We already know how to test it. It is in the document. Now we just need to find a way to automate it. And it sounded like really easy tasks. So we Googled some things, or I Googled some things, and I found a lot of information on the internet with different approaches, different solutions, or different frameworks and things that are solving problems that I'm not really aware what exactly the problems are. So we decided to go on our own and try to see basically what are the basics, what are the small little problems that we are going to hit through the journey, and then decide what to use. So we end up with a goal. We want to have as few tests as possible that are really easy to maintain and they find as many bugs as possible. How we come to this? Well, the total opposite is if we have a lot of tests and they're really hard to maintain and they don't find any bugs, this would be a total disaster. And we decided we don't want this, we want the total opposite, like a little tests that are really easy to maintain because we don't have the time to focus on this for months. And we want this test to be actually useful. We want this test to be able to find bugs. And if they're not finding bugs, that means that either we're too good of developers, which is probably not the case, or our tests, they don't do anything. So this was our end goal. We wanted to have as few tests as possible that are as easy to maintain as possible and captures as many bugs as possible. Here, looking at our backlog of bugs that we have had in the past, we realized that our backend is pretty well tested in terms of unit tests. We have thousands of unit tests, running them on every build. Our backend is mostly working. And same goes for the front end. It is covered with unit tests. We tend to not have any business logic on the front end, so the heavy lifting is done on the backend side. And our third-party integrations, of course, they're working, like payment providers, like streaming providers, sending emails, sending SMSs, all this stuff. They're solid companies and they work. But really often the integration between the front end and the back end and the integration between the back end and the third-party providers is the weakest point, is the point where things go wrong. So it was kind of obvious for us that we need to do end-to-end tests with browser, with real browser, real automated browser, clicking through the interface and testing stuff. Not any API tests, because our APIs, they work, but the relationship, the connection between the front end and the back end is not always working. So, okay, we are going with browser tests. This is first obvious solution to be made. Googling what are the best frameworks for browser tests, we end up with Playwright, Selenium, or Cypress. The top three frameworks that are out there. And we thought that this is going to be the most important solution. Once we pick the framework, we are good, and we just need to write the tests, which is entirely wrong. So doing a quick research and comparison, it seems like we have four really important things to consider. We wanted to write our tests in Python because this is the main language that we use for our backend. We wanted to be sure that we know the tooling, we know the language. Every developer can just hop into the tests and improve, update, add more, fix issues there. So this was one of our requirements. Another of the requirements was for the framework to work on Safari, because as developers we are not using Macs, and we don't really test the software on Safari. And the only way to test the software on Safari is to have a Mac. So we needed a framework that support automation tests on some kind of macOS platform using the real Safari in order to be sure that the front end is behaving properly even on Safari. We read about some issues around awaits. This is basically when you're doing an end-to-end test with the browser and you have an instruction like click on this button. If the button is not there yet, the framework needs to be smart enough to wait a little until the button appears. So Playwright was doing a good job with that. And again, we needed something that is approved and has a solid back of a solid company that is behind it. So it was kind of obvious that our tool of choice is going to be Playwright. We asked a couple experienced QAs, hey, what are we going to use? Everyone said, don't use Cypress. Selenium is fine. Playwright is a new thing, so go with Playwright. And we were, okay, let's give it a chance, since this is probably the most important decision. Entirely wrong. Let's give it a try. And this is how our first test looked like. If you're an experienced QA or have any experience with testing software, you can spot some pretty bad practices, but it took us like 3 minutes to write this, and it worked. What is happening here is actually a Python test that is opening the sign-up journey. It is entering an email, a password, pressing a submit button, and then asserts that on the screen you see a successfully registered model or something. And it was absolutely awesome. You run this code, a browser appears on the screen, someone clicks, enters some things, then press the submit button, and then a message appears on the screen. Totally awesome. Then you run it with your favorite test runner, in our case PiTest, because it is the test runner that we use in all of our projects, and everyone is familiar with it. Pretty powerful. And you just pass the headed flag, so it actually runs in headed mode. That means it's not headless, it is headed, so an actual browser is actually appearing on the screen. And it works. And it was pretty awesome. And then I decided to run again, and it failed. And it failed because a user with this email is already registered. So first time when you run the test, it works, but the second time it doesn't work because this email is already taken. And it was kind of disappointing, of course. And the first thing that we realized is that we have a shared state between each test runs. And all of our tests, as we know from unit testing, of course, should be independent. And they need to run in random order. So the order of executing the test should not really matter. In our case, we have a shared state between the test, and this is the database. So, okay, that's easy. We just need to get rid of the database. Our front end is stateless, our back end is stateless. The only place where we have state is the database. So we just decided to create an API and use it only for QA purposes that is dropping the entire database, just rebuilding everything, leaving only a super user and deleting everything else in the whole database. So before every test execution, we first of all call the backend, delete the API, code the API that deletes everything, and then do the test again. And it's working. Now this test is working every time when you trigger it. So you can trigger it once, you can trigger it like 10 times, it is working. Great. But our sign-up flow is not that easy. I mean, nobody's having just an email field and a password field, and then you press submit and you're registered. Our sign-up flow is way, way more complex, and this is really important for the sign-up flow to work. So, we have events that people are actually registering for, and if they cannot register because of a reason, things are not going well. This is the exact sign-up flow. We are using third-party integration to send emails, and then people need to receive their emails. They need to click on a button inside the actual email, so the template needs to be well populated. If the template is not well populated, then again the whole sign-up journey is not working. If the person is not receiving the email, then again the whole sign-up journey is not working. And after you click the button, you're getting back to the system redirected, approving your registration, and just continuing the journey there. And we have like different branches for the registration journey. It's way more complex than it should like. And all of the tutorials in the internet, they are around how to test your login form. And it seems pretty easy, but in reality, it's not that easy. So now we have a third-party integration that we want to involve is somehow in the test. We need to be sure that when we are running the test, we are testing how we receive emails, how we click on the link, and how we get redirected back to the platform. And this cannot happen locally, because locally we are not sending emails, of course. Locally we are having a different backend sending emails in the console, so we don't accidentally send thousands of emails to different people. And all the third-party integrations, like payment providers, like WebSocket integrations, for example, or sending SMSs, they are really hard to be configured to work locally. Not that we cannot configure them, but for example, some of them are sending webhooks back to the backend. That means that you need to set up some kind of local tunneling or VPN or something to expose your backend for integrations to hit it back. And setting up all the the third-party integrations locally, it's kind of a hassle. So we decided, you know what? Let's run these tests on staging. So on my local computer, I'm running my tests, and they're hitting staging. They're hitting the staging environment. So every time that I'm running the tests, every test is deleting everything on staging, running a single test, then deleting everything again, then running a single test again. Which works out of the box, and it works kind of good, but it has some pretty significant downsides. So we were at the deciding about, do we need to run this test locally, or do we need to run the tests on staging? And the obvious win here was staging, because it's really easy. You don't have to set up anything locally. If we have a team of QAs, they don't need to understand how to set up everything on their machines locally, Docker containers, databases, RabbitMQs, all this complexity. They just don't have to know it. About concurrency, if we have one environment that we are running tests on, that means that if someone is running tests, then no one else can be running the same tests or any tests. Why is that? Again, because we have a shared database. And if one test is dropping the database, creating some things, and the other test is dropping the database and creating some things, again, this is not any good. We don't have truly multi-tenancy, so you cannot create something only for a given event. Things are kind of shared between events. So there is no way for us to run tests in parallel if we are using staging. If you're running locally, you can have multiple QAs or developers having their own local environment and testing against it. But the truth is that locally things tend to work a little bit different. We mock some things, we don't send emails, especially when it comes to third-party providers. And yeah, locally it's way harder to set it up. Then we already had a couple of tests. It was going really easy, writing tests, running against staging, everything works as perfectly. At some point we realized that tests need to be maintainable. So they are part of the code base, and we as developers love to take care about our code base. And we need to follow some general rules. So things like avoiding code repetition. Some tests are kind of repetitive. So the sign-up journey, it has a couple branches, and we have steps in the branches that are kind of shared between the different test executions. So we don't just copy-paste them, but we introduce some kind of abstraction. The other kind of important thing is to abstract the DOM interactions away. So they don't need to be a part of your test. They need to be somewhere else. I'm going to show this in a minute. Proper asserts, so you know what exactly is failing, which test, better test naming, what exactly is failing. You're asserting that there should be a button that is red and it's named cancel. And if there is no such buttons, or it's grayed out or something, you need to know what exactly is going wrong when you see an error. And of course, readability counts. This is one of the most important rules for me for all the code base. So yeah, it needs to be easy for anyone to read a test and understand what exactly is happening and what exactly we are testing. Given that we are using Python, it's kind of easier, but readability is one of the most important things in the code base. So here in this example, we decided to, first of all, start hard coding URLs, like absolute URLs, and make it configurable. I can run my test against staging, I can run my test against local environment, I can run my tests against production, not recommended, and because it's dropping the database, of course, and I am running my tests, again, let's say development or multiple environments. So yeah, we have an environment variable that is telling the tests where to hit. Then we created this thing of page objects, which is nothing new. It is in the official documentation, and every framework is proposing of doing something like this. So all the DOM interactions are actually moved to page objects that are reused between different tests. So the only place where you define the selector for the email input, let's say, is one test, one method, one selector getting reused across the whole code base. And the test now is really shorter. It's like open the sign up page, fill email, fill password, click submit, assert, something is shown on the screen. And this was kind of nice, but it's not enough. We realized that the features that we are building are way too dynamic. They are changing like every week. Sometimes the designers, they just get inspired and they decide to redesign the whole thing, and then we need to rewrite all the tests because we are using the wrong selector types. So in terms of selectors, we have XPath. So the XPath is the exact location in the DOM tree of a given element, which if you change the order of the buttons, let's say, or if you change the something in the layout, XPaths are going to break like on the exact same moment. So they are probably the worst choice, but they're one of the ways. Another way is classes. We use classes for CSS styles. We use classes for we even use some tooling that on every deploy it is changing the CSS class, so it's preventing some kind of caching. This is kind of native to React, so we don't really have class names, or if we have, they change on every deploy. So this is something that we for sure cannot hook to. We have IDs, but IDs are pretty unique to the whole page, and again, we don't really use them in the project at all, so it's kind of hard to hook to a given ID. And there is another attribute that we saw on the internet that people are using called data test ID. My emoji is not showing on the presentation, but this is the one that we picked. Code looks like this, way more readable, way more understandable. But the thing is that you need to have a permission and the knowledge to change the UI. What do I mean? Like if I'm creating an input field and I know that we need to have a test for this, I'm going to place data test ID equals email field. And I know that this is the only email field in the page, and there are some tests, or there are going to be some tests written exactly for this field. This is kind of powerful and make the tests way more robust. We can change the entire layout of the page, change the colors, change the layout, change the positioning, change everything, and the tests are still going to pass. Another huge thing we discovered is never to hard code messages or any kind of strings in the tests, because they tend to change a lot. The designer decides that this is not the right message, so it's not like welcome to your new account, it is greetings or something like this, and then you need to change the text. So never hard code classes, XPaths, texts. Try to avoid this. Well, that means that if I'm writing a test, I need to have access to the actual front-end code base. I need to know what I'm doing there, because it's not it is not so obvious, especially if you're using some kind of modern web framework. And this is a part of our flow right now. Everyone that is writing tests knows how React works and knows how to add the proper selectors and basically change the code. So now you will ask, so what is the workflow? How do I change the front end while I'm writing my tests while I'm using the staging environment? This is kind of strange. So the solution that we came up is that you're running the front end locally, so you can change it and you can write your test properly, but it is calling the staging backend. That way the integrations are working. That way you're testing against real backend. It is just that you're changing the front end, like adding data selectors and writing tests at the same time. It is a little hacky, but until we have a good way to set up everything locally so you can write your proper tests, it seems like a good temporary solution. Okay, so everything that we've seen so far is oversimplified example of how a real tests look like. In the tests, we have a lot of setup, like you need to set up a lot of things before you actually run your tests. Let's say you want to test if the chat is working. Imagine a platform like, let's say, Twitch, where you have the chat on the left, and in order to test that, you need to have a registered user, you need to have a live event. This event needs to have a live stream active right now. The chat for this active live stream needs to be enabled, and then you can just enter the page and type something in the chat, which is a bunch of setting up and then the actual test. So how are we going to do these setups? For sure, we don't want these setups to be a part of the tests, because they are just random noise that we don't need. We need to focus on the important part, that is typing in the chat, hitting enter, and then the message should appear and everyone else should receive it. But the setup is like the thing that takes most of the time. Even when you're testing manually, like 90% of the time for running a test goes to setting up everything, setting up the correct state of the database and the integrations and everything in order to execute your test. So we found two obvious ways. We created an SDK that was just a library hiding all of this complexity from us. So the test looks like pretty simple, setup operations, and then the actual test. Everything that is in the SDK is a black box to us. Now, the other question is how this SDK is actually creating these things in the database, in the actual backend. One option is to create more custom APIs that are interacting with the database and creating whatever needs to be created there. And the other way that we think of is just clicking through the interface. Everything in our platform is testable through the interface. You can go to the admin panel and create an event, create a session, mark this session as chat enabled, and just have it there. So creating APIs is a lot more work. We already have the admin interface. Creating new APIs only for the QA purposes requires some more maintenance. We need to have tests for the APIs. We need to keep them updated. When a feature changes, we need to change this in the API some way. And again, we need to change the code for the tests. So there is obvious disadvantages that it's a lot more work. On the other hand, if you're just using the UI to build this SDK, you can have an SDK where when you run a method, it is just going to the UI and creating an event. Then you create a live stream and everything through the UI. And just have it as a composable individual pieces of code SDK that you can reuse. Not the only, but one of the disadvantages going with the browser clicking approach is that it's slow. Like if I'm creating everything that I need for my setup and I just need to make like 2 or 3 calls to the database, it's going to be way, way faster than every time opening a browser, going to the admin panel, logging in, creating an event, and then the next thing and then the next thing. That's why we decided to abstract it. At any given point, we can change the implementation and make our tests way faster. But for now, it is doing a great job. Now, tests need to be, of course, in a source control. They are a piece of code. They are an important piece of code that is getting bigger and bigger. And they need to be somewhere hosted, And the question here is where. And by where, I don't mean to which source control system. Git is the obvious choice here. But in which repo? We already have front-end and back-end repo. So the tests are kind of part of the front-end, but not entirely. They have some things from the backend that they consume. Are they going to live in a separate repo and have their own life? And I would say that this really depends on the team. We wanted to have a dedicated QA team that is not related in a lot of ways with the dev team. That means that they better have a separate repo, so we don't have this noise of commits, pull requests, everything in one place. And they obviously don't fit into the front end, they don't fit into the back end, so we decided to create a separate repo for them, which worked well. About running tests on CI. As developers, we always like automation, we always like making things faster, making things more automated. And CI is like one of the top important things in the whole project. We have a CI for the backend, running all the unit tests. We have CI for the front end, running all the front end tests, all the little utilities that we have, kind of unit tests on the front end. But do we need a CI for the end-to-end tests? And we decide this is kind of coupled with when we want to run them. Do we want to run them like on every release or on every commit or on every merge, or I don't know. So the truth here is that these tests tend to be kind of slow. They are, we are running them on different browsers. So that means we have 100 tests that we're executing on Chrome, then on Safari, then on Mozilla. Then we tend to run them on mobile devices just to see how the resolution is going and ensure the system is working on mobile devices too. And they take, let's say, 30 minutes, 40 minutes, 2 hours, depending on how slow actually are they. And they're slow by design. They are setting up everything and clicking from the UI. So what we decided to do is to make a nightly build that is running every night while we're sleeping, and then we have a morning coffee review. So it's posting a nice report in Slack saying, hey, these tests are broken, this test failed, here we have a problem on Safari again, here we have a problem on Mozilla, something like that. And every morning with the coffee, you can just review what's going on. Some of the tests are false alarms. So let's say it is working, but the feature gets changed and someone forgot to update the tests, or something strange is happening on the CI and we cannot really reproduce it. I will come to this a little bit later. But yes, running tests on CI is definitely something that is a must. And now the question is, when do we run them on CI? I would say nightly is fine, and before every release, it's fine too. Okay, then we come to a visual regression tests that are kind of important to us because, as you know, different browsers tend to interpret CSS in different ways, which requires a lot of testing. And it's really easy, how awesome is CSS, that only changing like one line of CSS code, the entire UI is broken. You cannot use it. It's so bad that you cannot find the button, right? And most of the cases, in most of the cases, if you're using some kind of framework like Playwright, the test is going to pass. That means that the framework is going to locate the button, even though it is, let's say, behind another element and you cannot actually see it. The framework is going to locate it and it's going to press it, no matter that you cannot really press it in the real life. So this is something really important to us, given that, of course, we may easily introduce a bug on a given browser because it works with the CSS in a different way. It's rare, but it happens. We needed a way to know how the things are looking, right? When you're testing manually, you have this eye contact with the monitor and see if things look good or they look broken to you. But if you're running automation tests, especially in the headless environment, you don't actually see the browser. And even if you see it, it's so fast, most of the cases, that you cannot spot issues. So what we decided to do is to create screenshots. Playwright support this. On every major step of each test, we have a function create screenshot, create screenshot, create screenshot. So type something here, create a screenshot. Go to a next page, create a screenshot, type something there. And this is part of the main test we have. So at every run, we have archive, a zip full of screenshots, let's say 200 screenshots, that are for different browsers, different resolutions, and it's kind of really easy for someone to download the zip and check all the screenshots manually for now. But a human can actually spot really easily a UI bug from a screenshot, no matter how many screenshots we have. Obviously, that's not scaling well, because if you have 2,000 screenshots, it's going to take you a lot of time for you to manually check everyone. So there are some tools out there for using AI to spot regression bugs, UI regression bugs, sorry, or there are some tools that are comparing the screenshots from the last build to the next build and checking if there is some differences and spotting you, highlighting you, saying, hey, we need a human saying if this is the new design or this is a UI bug, which is absolutely awesome. And the last piece that we did is stress testing. Client is always asking, hey, how many users we can handle? And we always don't know, given that the usage of such system is so inconsistent. Sometimes there is an event without any participants. Sometimes an event just blows up and everyone is watching it, right? So we cannot really predict how many users we are going to have at any given moment. So we need to know our limits. We need to be sure that the system can handle, let's say, up to 100K users without any problem. And where we actually have performance issues normally is not on the front end. It's a single page application. We are using some cloud storage to store the CSS and the JavaScript, CDN to distribute it all over the world. So chances of failing there are really low. Where we actually fail in terms of performance is the backend and, of course, the database. It's really easy, especially with Django and Python, to create an API that creates more queries in the database than you expected, and it is slow. And if you deploy this and a lot of people are hitting it, it has the potential to slow down the entire system, even take it down. So we need to be sure that our infrastructure is capable of handling, let's say, 10K people. Again, this is the point where we started using API tests. So we defined test scenarios for what the user is doing, only using the APIs. Let's say opening the list of streams, then selecting a stream, then putting something in the chat, then going to another stream. And with really nice Python tooling that we found, this is actually really easy. So as a conclusion, end-to-end tests are absolutely awesome. They are providing so much value, especially in the mission-critical projects as ours, that we cannot go without them. But they're code. We need to treat them as they are a proper part of the code base, take the needed attention to the tests, and just know that they need to be readable, understandable, and they need to be into the good shape. And they need maintenance, feature changes, design changes. We need someone or multiple people to take care of the tests, update them frequently, and just write them in such a way that they don't change, that they don't break so frequently. And it is a decent investment. That means that it is not something that we can do on the side while we are developing the platform. It is something that we need to take proper attention, and it costs a lot. So if the project is not mission critical, it's not so important, it is something that we're doing on the side, or nobody is going to have hard time because the system is not working for some time, or some feature is not working for some time, then it's probably not worth it. So yeah, we need to keep this in mind as developers. Once again, thank you. I was Ivaylo Bachvarov, and now it's time for questions.
Thank you, Ivaylo. So we have a few questions in Discord already.
All right.
If the audience has more, now is the time to ask them. So the first question is from Miriele. Earlier in the presentation, you said don't use Cypress. It's highly recommended these days to be used instead of Selenium. So why is that?
I don't know. I mean, my point was that we asked a lot of QAs that have like a lot of experience, and they said Cypress is not there yet. One of the main reasons that we didn't choose Cypress is because at this point of time that we took this decision, it was not supporting Safari properly. So this was a deal breaker for us. And the other thing was that we couldn't use it with Python. And this was the leading decision. Our core backend is Python. We know Python. We know all the tooling. We know how to handle exceptions. All these things that are pretty common in the tests, we know them. So our main choice was based on, again, Python and needs to support Safari. This was the two must-haves.
Cool, thank you. So we have another question from Pam Nikolaev. So you did employ a CI/CD automation system. You run them by them. You said that in your application. What kind of system did you use?
We are huge fans of GitHub Actions as a CI. There is one limitation that a build cannot be longer than 1 hour, which for end-to-end tests sometimes is too low, but we are trying really hard to keep it faster than 1 hour. So we have not reached the limit yet. GitHub Actions works great. We are happy of using it because you're using GitHub and it's kind of connected and everything's there. But I would say that everything else would work. I mean, CIs, they're kind of all the same.
Cool. So you said that you were planning to have as fewer tests as possible in the beginning. How many tests did you end up having?
Okay, so we end up having around 100 tests, let's say. We went to this journey of creating some tests, then we realized, okay, this is kind of duplicated here. We don't need these tests. Let's better just delete it and hope that the other test is going to capture this. So deleting a test is something that I was kind of afraid at the beginning because it's kind of a lost work, but it is really helping to end up with faster test suite, less tests, and easier way to maintain your tests. So yeah.
Cool. So you have another question, and we saw that you are dropping the database for every test. Was that slow, or compared to the other things that these tests did?
Well, we're not like dropping the whole database and creating it entirely like creating all the tables again. We are just emptying the tables, and we were smart enough to optimize this in some way that it is like creating a cache, and we are not like doing it. We kind of optimized this, and this was fast enough. And we were on another level that we introduced some common presets, so things that we need for every test, like the basic things, like a super user, a token for the super user, like things that are used across every test. And this helped too, so you don't need to set it up in every test.
Cool.
It was like combined, dropping and creating some stuff.
Cool. So those are all our questions. Thank you again, Ivaylo. You folks, we'll be back at 4 p.m. with the talk.